Thank you for stopping by helpyourmath.com. In this video, we're going to look at rationalizing the denominator. Specifically, we're going to look at examples where there are two terms in the denominator. So if there are two terms in the denominator, let's just call those terms a plus b. So we're going to have, we're going to have x over a plus b. The way that we can rationalize the denominator, in fact, I'm actually going to make these radicals just so that it already starts out being irrational. What we do is we actually multiply by the conjugate of the denominator. So the conjugate is when the two terms are the same, but the sign between them is different. And whatever I do to the denominator, I need to do to the numerator to keep it a factor of 1. And so if we look at the denominator, root a plus root b times root a minus root b, we end up with root a times root a, which is a, minus the square root of ab, plus the square root of ab, and then we have minus b. So what ends up happening is those middle terms cancel. The part that had the radicals cancel, leaving us with a minus b, which should be rational. So that's basically what we want to try to do here, is we want to multiply by the conjugate of the denominator. And we multiply both the numerator and denominator because that's what we do with fractions. So our first example, we have the square root of 5 divided by the square root of 5 plus 3. In order to rationalize the denominator, we need to multiply by the conjugate, which would be the square root of 5 minus 3. We do the same thing to the numerator, the square root of 5 minus 3. And then I suggest simplifying the numerator, simplifying the denominator, and then putting them back as a fraction. Otherwise, it can just be kind of labory and annoying. So this would be the square root of 5 times the square root of 5 minus 3. Square root of 5 times the square root of 5 is 5. And the square root of 5 times negative 3 would be minus 3 radical 5. So we see we didn't quite rationalize the numerator, but that's okay. We don't have to do that. It only asked us to rationalize the denominator. Looks like my pen is going to be a little strange. That's okay. And now we have the square root of 5 plus 3 times the square root of 5 minus 3. That would be root 5 times root 5 is 5. Root 5 times minus 3 is minus 3 root 5. Here we have plus 3 root 5. And then we have 3 times negative 3 is negative 9. So we see those cancel, and 5 minus 9 is negative 4. All right, so now we're going to put everything back together. Our total rationalized denominator will be 5. No, it's going to be weird. Okay, we're going to go over here. Maybe it'll work better over here. Ooh, beautiful. 5 minus 3 root 5 divided by negative 4. We can leave this as our final answer. You can split the two up if you want to. I would just, less is more. Just leave it like this. In our next example, we want to rationalize the denominator, so we need to multiply by the conjugate, which would be the square root of 7 minus the square root of 11. We do the same thing to the numerator. Now we're going to simplify separately. So the numerator, we have the square root of 2 times the square root of 7 minus the square root of 11. This would be the square root of 14 minus the square root of 22. And that's all we can do. 14 doesn't have any perfect square factors besides 1. 22 doesn't have any perfect square factors besides 1. So we'd be good to go. Let me see if I write down here if that's better. Nope. Okay, we're going to put it over here. Okay, it's still bad. Oh, it's better. All right. Now we're going to look at the denominator. We have the square root of 7. Nope, got worse again. Plus the square root of 11 times the square root of 7 minus the square root of 11. The square root of 7 times the square root of 7 is 7. This is going to be minus root 77. This is going to be plus root 77. And root 11 times negative root 11 will be minus 11. So here we see the root 77 and the negative root 77 cancel. 7 minus 11 is negative 4. That's just a coincidence that this happened to be the same as the denominator last time. Putting it all back together, we're going to end up with the square root of 14 minus the square root of 22, all divided by negative 4. And we can't simplify anything because negative 4 is rational. Meanwhile, the square root of 14 and the square root of 22 are not. In our next example, we want to rationalize the denominator. Shocking. We're going to multiply by the conjugate of the denominator. That would be root 3 plus the square root of 13. Root 3 plus the square root of 13. And now we're going to focus on the numerator. So the numerator, we have the square root of 3 minus 4 times the square root of 3 plus the square root of 13. So here we need to do the double distribution. We have root 3 times root 3, which is 3. Root 3 times root 13, which is square root of 39. Minus 4 times root 3 will be minus 4 radical 3. Minus 4 times the square root of 13 will be minus 4 square root of 13. None of the radicals can be simplified. They don't have any perfect square factors besides 1, and none of them can be combined because all the radicands are different. So that's the best we can do with the numerator. Hopefully we have better luck with the denominator. With the denominator, we have the square root of 3 minus the square root of 13, and the square root of 3 plus the square root of 13. Giving us, we have root 3 times root 3 is 3. Root 3 times root 13 is square root of 39. Minus root 13 times root 3 is minus root 39. And then minus root 13 plus root 13 will be minus 13. Those cancel. We have 3 minus 13, which will be negative 10. So now we're going to bring this all back together. We have 3 plus root 39. Oops, shouldn't be a plus sign. Minus 4 root 3 minus 4 root 13, all divided by negative 10. And there's no simplifying that can happen. The radicands are all good. There's no like terms, so that would be the final answer. Okay, in our next example, I see everything here is irrational, each term. We're going to multiply by the square root of 5 plus the square root of 3. That would be the conjugate of the denominator. And we're going to multiply the numerator. So looking at the numerator, the square root of 5 plus the square root of 14 times the square root of 5 plus the square root of 3. Root 5 times root 5 is 5. Oops, how about square root of 3? There we go. Root 5 times root 3 will be the square root of 15. Root 14 times root 5 is the square root of 70. And root 14 times root 3 would be the square root of 42. Looking at this, I don't think anything can be simplified. 15 is 5 and 3, 70 is 2, 5, and 7. 42 is 2, 3, and 7. So that's what we're stuck with in the numerator. Just like last time. In the denominator, we should have better luck. We have the square root of 5 minus the square root of 3 times the square root of 5 plus the square root of 3. That's going to give me 5 plus the square root of 15 minus the square root of 15 minus 3. Those are going to cancel, and 5 minus 3 is 2. So putting it all back together, we have 5 plus radical 15 plus radical 70 plus radical 42, all divided by 2. And nothing can be simplified. We've already checked all the radicals. In our last example, this time we have radicals and coefficients, so just a little more work to finish these examples off. We're going to multiply by the conjugate of the denominator, 3 radical 6 plus 8 radical 7. 3 radical 6 plus 8 radical 7. And negative 2 radical 6 plus 3 radical 7. This is the numerator. I'm sorry, I didn't label it. Numerator. Times 3 radical 6 plus 8 radical 7. Okay, we want to be really careful when we have regular numbers and radicals. So here we have negative 2 root 6 times 3 root 6. Well, negative 2 times 3 is negative 6. Root 6 times root 6 is 6. So it's negative 6 times 6, giving us negative 36. Here we have negative 2 times 8 is negative 16. And root 6 times root 7 is square root of 42. Here we have 3 times 3 is 9. And square root of 7 times the square root of 6 is the square root of 42. And then lastly, we have 3 times 8, which is 24. And then root 7 times root 7 is 7. So it's going to be 24 times 7, which is 168. We do have like terms, so we want to combine our like terms. We have negative 36 and 168. So when we subtract those, we end up with 132. And then we have negative 16 root 42 and positive 9 root 42 will be minus 7 radical 42. We cannot simplify root 42. There's no perfect square factors besides 1. So we're done simplifying the numerator. In the denominator, we have 3 root 6 minus 8 root 7 times 3 root 6 plus 8 root 7. And again, we want to be really careful. When we multiply regular numbers, we get regular number answers. When we multiply radicals, we just need to be really careful. Okay, so 3 root 6 times 3 root 6. 3 times 3 is 9. Root 6 times root 6 is 6. And 9 times 6 is 54. 3 radical 6 times 8 radical 7. 3 times 8 is 24. And radical 6 times radical 7 is radical 42. So that's going to be plus 24 radical 42. Here we have negative 8 root 7 and 3 root 6. That's going to be minus 8 times 3 is 24. Root 7 times root 6 is root 42. And lastly, we have minus 8 radical 7 times 8 radical 7. Well, minus 8 times 8 is negative 64. And negative 64 times 7 is 448, negative 448. Woo, that's a huge number. Okay, now look what happens. Yay, those cancel as they should. And then we want to combine the two rational parts. When we subtract 54 by 448, we end up with negative 394. So now we're ready to write our final answer. We have 132 minus 7 radical 42 divided by negative 394. I don't think we're going to find any common factors because 132 is not divisible by 7 and we don't need to check anything else. So this would be our final answer. Thanks for stopping by.